Welcome to MRL. In this learning session, or rather this is the third part of learning of sequences, and in this part we'll learn a few important applications of arithmetic progression or the knowledge of arithmetic progression. Now if you are asked to establish a relation to find the sum of natural numbers, you are given the natural numbers, a set of natural numbers 1, 2, 3, 4 and so on. We want to find out the sum of natural numbers. As we know, natural numbers is a sequence. Natural numbers is a sequence, or group of natural numbers is a sequence, and therefore we can use the property of arithmetic progression. Now in this we are given 1 plus 2 plus 3 plus 4 and so on. We have to find Sn, that is sum of natural numbers. Now we know the formula Sn is equal to n upon 2 in the bracket 2a plus n minus 1 into d is the formula to find out the sum of numbers, n numbers. And here a is 1, the first number is, or the first term is 1, and the difference is 2 minus 1 is 1. You know that t2 minus t1 is the common difference, and therefore t2 minus t1 is 2 minus 1, and that is 1. So knowing a is equal to 1 and d is equal to 1, we have to substitute here the value of a and d. So n upon 2 in the bracket 2 into 1 plus n minus 1 into 1. N upon 2 in the bracket 2 into 1 is 2 plus n minus 1. The n upon 2 in the bracket n plus 1, because 2 minus 1 is 1, n plus 1, therefore Sn is equal to n upon 2 in the bracket n plus 1, or summation of natural numbers or sum of natural numbers is equal to n in the bracket n plus 1 upon 2. Therefore remember, the relation to find the sum of n natural numbers is n plus 1 upon 2. For example, if you want to find out the sum of 50 natural numbers, then 50 into 51 divided by 2 or 25 into 51 will give you the sum of what you call 50 natural numbers. A very easy formula to find out the sum of natural numbers. So that is what is the application of arithmetic progression here. So also let us learn one more important application to find out the sum of even numbers. Now what is given to us? We are given 2 plus 4 plus 6 plus so on up to n terms is the sum of even numbers. As you know, even numbers also form an AP, and therefore we can find S1 using the formula of finding out Sn for AP. Sn is equal to n upon 2 in the bracket 2a plus n minus 1 into d. Here a is 2 and d is 4 minus 2, that is t2 minus t1, and that is 2. Substituting the value of a and d, that is n upon 2 in the bracket 2 into 2 plus n minus 1 into 2 will give us n upon 2 in the bracket 4 plus 2n minus 2. Simplification further gives us that is 2n. 4 minus 2 is 2, 4 minus 2 is plus 2, and n upon 2 into 2 in the bracket n plus 1, n in the bracket n plus 1. So this is the formula, that is Sn is equal to n in the bracket n plus 1. Therefore the sum of even numbers can be found out by the relation n in the bracket n plus 1. For example, if you are asked to find out the sum of the first 10 even numbers, then it will be 10 into 11. 10 into 11 will be 110. So that is how we can use arithmetic progression to find out or establish the formula to find out the sum of even numbers. And so also we can establish a formula to find out the sum of odd numbers. You know that odd numbers also form what you call an AP, and therefore we can find out the sum of odd numbers 1 plus 3 plus 5 plus on using the formula of Sn for AP. Sn is equal to n upon 2 in the bracket 2a plus n minus 1 to d. A is equal to 1 and d is equal to 3 minus 1, that is 2. Substituting the value of a and d here, we get n upon 2 in the bracket 2 into 1 plus n minus 1 into 2. Simplifying, we get n upon 2 into 2n, that is equal to n into n is n square. Therefore the sum of odd numbers can be found out just by using the formula n square. For example, if you want to find out the sum of 25 odd numbers, then it is 25 square, that is 625. So very easy to find out the sum of given odd numbers. So that is again a very important relation we established using the basics or the properties of arithmetic progression. Now the next important study is arithmetic mean. If you have three terms, A, capital A and small b are in AP, that means A, B are in AP, they are in AP, these three terms are in AP. Then by definition of AP, we have A minus A is equal to B minus A, that is T2 minus T1 is equal to T3 minus T2, they are equal, because common difference, they have a common difference or a constant difference is same. Now transferring A to the left, we got A plus A is equal to A plus B, or 2A is equal to A plus B, and A is equal to A plus B by 2. Now what does this mean? That means the middle term, the center term, in three terms the middle term can be found out by taking the average of the first and the third, that is A plus B by 2. So the middle term is the arithmetic mean of the first and the third term. Or we also can say that a plus b, that is the sum of the first term and the third term, is twice the middle term, that is what is, or the second term. So that is how, that is what is called as arithmetic mean. So arithmetic mean is average of the first and the last term if the given three terms are in AP. Remember that. Now if you are given to find out the nth term from the end of an AP, always remember we start with the first term and end with the last term, and the formula for finding out the nth term is Tn is equal to a plus n minus 1 into d. But if you want to start with the last term and then end with the first term, then the nth term will be L minus n minus 1 into d. Remember that L is the last term here, minus n minus 1 into d. It's a relation very useful again to find out the what you call the last term and d is the common difference, and therefore that is the nth term or the last term. So instead of using Tn is equal to a plus n minus 1 into d, we can use to find out the sum of that is the nth term from the end of an AP. The formula will be L minus n minus 1 into d, or else we can use same a plus n minus 1 n into d, but we have to use d as minus d. Therefore I suggest use Tn is equal to a plus n minus 1 in bracket, use it as minus d if you want to start from the last term. Anyway, we'll learn this with an example when we study about the application of AP or finding out the terms of an AP. Now properties of AP. If you addition of a constant k to each term of AP, the resulting pattern is again an AP with same common difference d. That means you are already given an AP, and if you add the same term k to every term of the given AP, then the new AP formed is also an AP and they have the same common difference d. Now subtraction of constant k. From every term of given AP, if a constant k is subtracted from each term of the given AP, then the new AP formed is also an AP with the same common difference. Now the third important property is, if you multiply every term of an AP by k, then each term is multiplied by k in the new AP, and the common difference will be k into d. If d is the common difference of the given AP, then the new AP will have a common difference of kd. And the fourth important property is, if every term of a given AP is divided by a constant k, then the new sequence is formed is also an AP, but the common difference now is the d upon k. Remember that these are the important properties of AP. Now here I have given you how to select the terms of an AP for easy calculations. In mathematics, we are using AP for different calculations, and depending upon the number of terms given to you, we have to choose one of these. For example, if 3 terms are required, we can go with a plus d, a plus 2d, but that will be a difficult calculation because we have to find out 2 variables, whereas by using these 3 terms as a plus d, a minus d, a plus d to the right, a minus 2 to the left, then common difference is d, then here d gets cancelled out, only one variable has to be found out, that is a, so the calculation becomes easy. So when 3 terms are required, use this pattern, that is a plus d and a minus d, a plus 2 to the right, a minus d to the left. If 4 terms are required, then start with a plus d, add 2d, then you get a plus 3d on the right, minus 2d will get a minus d, again minus 2d will get a minus 3d. So these are the 4 this is the pattern which we have to use if 4 terms are required, and the common difference will be 2d. If 5 terms are required, then start with a, add d, that will be a plus d to the right, again add d, it will be a plus 2d to the right, and subtract d, a minus d to the left, and again subtract d, a minus 2d to the left. So therefore the pattern is a minus 2d, a minus d, a plus d, a plus 2d with a common difference of d, very useful in calculations. And if 6 terms are required, then start with a plus d to the right, keep adding 2d, a plus d, a plus 2d will be a plus 3d, again 2d will be a plus 5d, adding, then subtract 2d here, a plus d becomes a minus d, again subtract 2d, a minus d becomes a minus 3d, and then a minus 5d. So these are the 6 important terms which are in AP and very useful in calculation. The importance of this pattern which I have noted here or given to you is that the d gets cancelled out in each case, only one variable has to be found out, and therefore the calculations becomes very easy. Otherwise you will get if you have to find out 2 variables, then there will be 2 equations. That means you have to solve those 2 equations and then find out the 2 values of a and d. Instead of that, d gets cancelled using this pattern. So these patterns are generally used for making our calculations easy. So remember these patterns, and they have their own applications in mathematics. Very important pattern, remember. So we have studied about arithmetic progression and its important properties and a few important applications of AP. In a different learning session, we'll be learning to find out the different terms of AP and also applications of AP. That will be a different learning session. So now in the next learning session, we'll be learning about the next sequence, that is harmonic progression, and then we'll proceed to learn about geometric progression. Okay, thank you.